Um, Hi, I think I'm live. Yeah, this is very weird position because I applied something to my hair, and because of which I am kind of in a locked situation. Cannot do anything else apart from sitting. Yeah, they say why not? It's been a long time. So, yeah, let's quickly start. Okay. Um, why this weird angle is I'm kind of shirtless, so please don't. Yeah, let me open. It's only one. So, what is this dream exactly? So, um, it's just a chill stream. So, I wanted to share about my perception on some of the things. It's not opinion or something, that what I believe that I learned uh, in quite few years, like 2 years maybe. Yeah. So, okay, instead of what I'm thinking was, instead of giving this a title and go through that narrow type of title, let's make it so random, so that we start with this much of a band, so we narrow it and come to the point. I think that's how things work. um, so 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 like, most of my channel content will be around software engineering because that's my regular or full-time job. So, what is it like? What is the main component? So, what uh, what kind of software or hardware part of stuff, and what exactly is existing, and what can be done? Something like that. Again, even I'm not able to say anything because it's so random. Um, so we have, I think, if I'm not wrong, by software I mean applications. So we have hardware where the registers, buses, yeah, the hardware component, CPUs, memory, communication between those two, like that. And this is like something very important, which is also a kind of software itself. But since it's a bridge, we call it differently, like operating system. So ultimately, whatever we do, what like you build from basic to-do list app or calculator app to a gigantic web application or microservice based or whatever, everything should happen within the hardware, with in the scope of the hardware. So there should be something, and hardware only understands zeros on one side. So there should be only some things to do that. And yeah, OS is also software. This basically where um, I did my education like BTech on this, and yeah, I'm doing right now. I'm here right now. So which this is also called as layer 7 application layer, where we will. So just a second. Okay. I just want to make sure that all of my faces. Oh, we have one viewer already. Okay, cool. Uh, so so how wider it is. So whatever we do now, I also feel like these things are very important. communication, not peer to peer, not uh, between the people. When I mean whatever I mention, he is here by default meant for software. If it's meant for any other thing, I think I'll put it up. Communication between two systems. So as like um, here I'm talking YouTube, and all you guys are seeing. If not, I think so. One person is seeing. So whoever, right? It's a communicating. We are communicating, and he is able to see what I'm speaking, and he is able to see what I'm writing, kind of thing. So basically, I'm communicating with, let's say, 10 people are seeing my content. I'm communicating with 10 different persons, um, and whatever is happening here, they are immediately seeing there. So that's kind of very quick construct. So one thing is communication is what um, I think drives this, and because of what we say something called as internet. Second one is second one is storage. So okay, second one is storage. So we get a lot of data, right? We need data for so many things. We need data for presenting it to users in different format. We need data to show another data to user. We need data. So basically, we need data for user purpose only 90%. So three things we can do on data. Okay, let me put in a different purpose. Three things we can do on data. Let me put it here. We can write data here. One, we can do storage. We have to do data instead of transfer. Can I say data movement? Yeah. Transfer, data movement, and computation. Yeah. I think these are the three primitive and basic operations that we can do on a data. We can do many, but I think any of other will fall between these three categories. Again, this is just what I thought, what I think, and there is no specific, that I have prepared from somewhere. I have read this somewhere, and I'm telling it. So I may be wrong, but yeah, let me know in comments which part I'm wrong or something like that. But we have warehouses like Databricks warehouse or Amazon warehouses, whatever, where we store lot of incoming of data from millions of users interactions with the software applications. For example, you scroll Instagram, you keep searching for the stuff, and how do you get recommendations? Because they collect each and every interaction of yours with the application, and they use it. They store it in a data warehouse, and they do some kind of computation over there, and where they that turns out into useful data for you. So, in terms of financial applications, we do storage and computation where, like whatever money based transactions, um, between two persons or two businesses or whatever. And this also has again some things replication or effective storage, how to store optimally, indexing for retrieval and stuff. Moment is where communication is also comes part of data communication. So two systems or two applications are communicating with each other, or transferring data from one system to another system. That's called as data movement. For example, um, I'll be getting weather updates for every second based on the uh, weather data collected by weather stations or something. That data will be uh, continuously updated by the APIs or endpoints that will provide, and I keep pulling data from that endpoints, something like that. Or you can say from LLMs. Uh, each token will be streaming from its response to the UI or something like that. So data communications, yeah, I think these two combination is something called as networking, where I don't know, would be talking. Here comes the big boss, networking. So before anything, right? Before see from computers being evolved when the first computer was as much as a big room, networking started, coming out where it's like multiple people will be in the same network and communicate over the network or something like that. And this is a rabbit hole. I I think I'm being too. I don't know. Maybe I might be wrong, but this is a rabbit hole. So how much ever you deep dive inside it, it is so well established, and yeah, you'll end up zero. Like you go deeper, deep dive. At one point, you feel like it's just the dots, and it'll take really lot of time to connect, because obviously, like, this is years of work of worldwide geniuses. So their lifetime learnings, inventions, creativity, all this stuff comes here. Mm, a small story of this I wanted to share. So when I was in my final semester of the college, I really got interest in this protocol called as TCP. Um, so, well, I say, like, for example, I'm what's the triggering point was, I was talking with my friend on WhatsApp call, and you know how it breaks in a bad networking. Uh, when it's a bad network, right? So when he started speaking, I got 10 words in the same word. Like, it's just 2x in the same word. Like, for the 2 seconds, I hadn't heard anything. In the third second, the 2 seconds data plus the third second data, it just flushed into my device, and I overheard it. So I was like, how is it possible? Because the 2 seconds words would have been lost somewhere in this network, and somehow the client side of his or whatever, uh, mobile or router or WhatsApp application, able to do that. So I was like, chalo, let's go deep dive into TCP. We have a lot of time. So I wanted to go really depth, and I kept, I guess, around 3 months, 3 to 4 months. I started like TCP, like starting from the full form, making zero knowledge out of it. Um, why zero? Because I had very little bit knowledge, because I know most of us doesn't hate computer networks in our college curriculum, because the way how it's been taught, right? Yeah, just add some units or chapters to each unit, and some protocols, random protocols without any connectivity. Just complete the course. Yeah, that's how. Yeah. So when I started digging deep over TCP, transmission control protocol. So it's in which layer? It's in transmission layer, and how does it go? It should be fine. In diagrammatically, it will be fine. But when you try to draw between end to end between two systems, computer A and computer B, and is trying to send packets in different way. And there is, in communication, there comes modes of communication also. A request response. For every request, you respond for the requested query or something. And yeah, if you don't have exact answer, and if the answer, the source of the response is moving, you do something called as streaming, or yeah, like that. So so when you see that in a big picture, and you see how it handles the packet loss, and I went deep dive into that, and I'm gone, like, nothing. 30 days, I went inside, and if I look back, close my eyes for 5 minutes, and if I see everything is same, I gained nothing. In fact, I started confusing more. Um, what is happening? Why is this router coming in, switch coming in? What are the layer 0, 1, 2 doing? What's the role of that? How is that helping TCP layer? And what is happening above the TCP? All these are just the dots. You will be touching many dots and you won't be able to connect many of them. I felt fair because I understood the depth of this, and very soon I realized it's a rabbit hole. And reading it conceptually doesn't bring me anything, as until and unless I had a, maybe if I go to some company working as senior DevOps engineer or like that, where I work with closely with networking and stuff, maybe I'll be able to get the crux of it. But yeah, networking is one such rabbit hole where should be really careful to show the interest in. Yeah, but I'm not saying if you are interested, drop it. It's up to you. But sooner you will realize. Yeah. I realized for me it's a rabbit hole. For me. And then networking builder slowly people started inventing www, World Wide Web, and since you have access to web, and there's all this IP address, node address, and MAC address, all this stuff came, and the concept of data centers came. So where you start holding other computers in the data center, that's so basically server. So one more dangerous word is called as server. It's a very dangerous word. Uh, I'll tell you why it's dangerous. Yeah, I'll come to this. So you have data centers and which has hundreds and thousands of servers, and how your laptop or how my laptop needs power for working. Similarly, server also needs power to work. And imagine uh, you are this is a computer used by hundred, millions of people. There should be the current supply to that in a similar way, and hardware also should be in the similar proportion. This server can be the same as my Mac's hardware because yeah, obviously for some limitations issues. This has to be super fast and yeah, what not. So yeah, servers came up and people started building web applications, and slowly protocols like FTP, SMTP, I think, secure mail transfer protocol, and very famous HTTP. All this comes like WebRTC, gRPC, all this like I don't know. I'm not telling in any of the order. Just the random protocol names that I'm remembering and I'm putting it here. So there is a background story of invention each protocol. And one more thing I learned is actually uh, when you are learning something, see through builder's perspective. What does it mean? For example, take Kafka. So so if you see Kafka, right, from the usage point of view, it looks, you feel like, what is this, all this? You need to start about proto buffers, you need to know more about OS and what operating system it's running, and so many things. Kafka is something that kinds of uses almost 90% of this hardware, OS, software applications. It's a hell of technology. So it's a wonder. Kafka is wonder. And if you see from that perspective, you feel exhausted while learning. For example, it, it will take a lot of time in order you to learn about internals of broker, Kafka broker. Yeah. Is there any necessary to learn internals of Kafka broker? Not, not really. But again, when you want to become a better engineer, you have to learn internals of the abstracted components that you are using, so that you can have a hold of, you can have a grip or hold over what you're working on. Something like that. Yeah. When you see Kafka from other side, say see from the builder's perspective, what I mean. So now you have producer, now you have consumer. What and all should my qualities or properties of my Kafka broker, so that this communication part will happen very seamless. That's what I mean from builder's perspective. Yeah, you can increase this. Yeah. Where are we? Yeah, here web something. So we started building, HTML came, and mainly this browsers came where you can interact with. So this is a YouTube server somewhere in American things, and somewhere in America, and from here as a client, I'm interacting with it. I'm I'm establishing a communication to that particular instance of a server, and I'm communicating with it. Whatever actions I'm doing, it's computing. Maybe right now it's recording my life, and started storing it or something like that. It's doing its part. What it meant for. So, um, yeah. Again, I think I lost where are we? Yeah, yeah. I think this protocols part. Yeah. So servers came up and people started building web applications, because it's a one of the easy way to interact with it, where you talk to that server, and other persons also talk to that server. It's like a middleman between you two. So what is server? Yeah, this is my, again, one of my you see this interact interchangingly used everywhere. uh, is a YouTube server and MCP server share something same? Why is MCP server is called as server? Um, it's not a computer, right? It's MCP server is not a computer. MCP server is not a hardware, where it has memory and RAM and processing engine. It's not a hardware bounded server. But why is it called as MCP server? And why is your Postgres server? Why is Postgres is a server? So answer is, what is server? Server is something that takes request and gives response. Yeah, that's it. That is the only definition of server. Nothing else. And this is as simple as that. For example, say my MySQL server. If when I say MySQL is a server, if I'm sending a query of a database, select this, that is my English readable format. MySQL server kind of breaks that statement into the executable things behind of that processing engine or something like that. It does that part of that, taking your language and converting it to something else, so that MySQL can execute and do operations on the data and gives you the output. So takes the request and gives the response of your query. That is why MySQL is a server. Why MCP is called a server? MCP is a server because that takes the request from an agent and gives the response based on the tool output or something like that. That's why it's called an MCP server. If you are storing the information somewhere, then that server will be having the ROM, RAM, and computational power like that. If you're not, like MCP server doesn't need any RAM, ROM, so it's not to be hosted somewhere. It's an application, right? It's not a hardware server. And this term will be interchangeably using in many places. So I thought this would also be a good one to discuss. Yeah. And yeah, so then next question is, how do you interact with servers? So let's make an arrow, right? Again, I don't know. Yeah, I'll move that little bit that side so that I can. Yeah. Now let's see how to interact with server. Now you have something called as you're saying, hey, you send me a request, I send you a response. This is what we agreed for. Is what we agree. It's not done. Yeah. Series on. Yeah. So yeah, now if we tell about how to communicate with server is where protocols come into picture. So if this server is in different or somewhere, you need to download from the server, you need to use FTP. If it's a mail or Gmail server, you need to use SMTP because that has also some rules. Protocol means what? It's a rules, right? And the one and only very famous protocol HTTP, where yeah, I'll come to HTTP. So with servers came protocols. With protocols, we got okay. With protocols comes APIs. APIs is how is one of the way, maybe most part of the way, maximum way that we interact with the server. And yeah, clients sends requests to server at different endpoints. What component has to be served? For example, I have hosted a server in maybe in some data center or in some cloud or something. Now, if I want to ask the list of all the employees in a current company, how will my server respond for that query? So basically, I should have an endpoint, and when that endpoint is hit by the client, I kind of write a logic inside that specific endpoint saying that select star from employees and return it. That's it. And yeah, APIs kind of categorizes what the server should respond to user query, and all these APIs can be triggered or invoked by users interaction with the website. For example, when I when I open my when I open my what should I open? GitHub, Raven GitHub, GitHub.com. Yeah, maybe after signing in. Okay, when I open something and if I ask my search history or something in YouTube. So when I open YouTube and if I click on my search history, all this comes. That's because if I click on the search bar, that would have hit the slash search APIs and it shows the search history as that logic to fetch the search history and show in the UI. This is where most of the web applications fit in, servers and APIs. And and a very important part is our Chrome or browsers also play very important part um, in the web applications that we build. How? Uh, mostly the APIs are invoked by HTTP, which is a stateless protocol. I don't know why uh, this is. I don't know why this text is so much. It is, yeah, HTTP is stateless. Why stateless? Uh, Yeah, HTTP is a stateless because when they started designing web applications back then, websites was a thing. They wanted to build a simple protocol that takes a user request, send a response. As I told that time, the web scope was very less, and it was just for request and response. You send some request, you give the response. Maybe style.js or style.css or index.html pages rendering, uh, viewing images, and stuff like that. So HTTP aim was simple. User sends a request, you send a response, done. Done from both the sides. Now HTTP, there are disadvantages came over this idea, because they design this. That's why I mentioned uh, see through builder's perspective. So when they invented or created this, they didn't know that web will become such a thing in future. So passed down the years, so the servers were down and users were not able to extract or fetch any information or anything from any of the servers. Why? Why is because, for example, there is a server. There is a server in, and as I told, it's a computer, right? It has something called RAM. It has something called ROM. It has something called CPU. Yeah, CPU. Now, when system A, let me make it plain. I'll move it this side. Okay, move it this side. So, when I make um, a client here, which is Chrome, and this is Chrome A. Similarly, you'll be having. I'm getting a phone call. So, there are three, four Chromes. Okay, maybe assume this like a user. Chrome 1, Chrome 2, Chrome 3. You have three users. From imagine from a Chrome, they are sending a request like this. So what happens was, when Chrome one user sends a request saying that, hey, get my account balance. What it does is, it no, there is an endpoint that does database logic at the down. It uses CPU and RAM and data present inside ROM, and computes that balance and sends as a request, and this connection is gone. Main thing in HTTP was, for every request response, the connection is gone. And when the Chrome 2 also, user 2 also asks, send me the balance of my account, send me the balance of my account, it also establishes HTTP connection, and after the response being sent, connection is being cut. Same with the Chrome 3. Now, why is it a thing? Why HTTP can't be this simple? What is the disadvantage of this? Was HTTP works in a layer 7 application layer, below which there is one dangerous protocol called as TCP. That is a problem, and you cannot change TCP, as internet already evolved over that. And the only thing you can do is changing the HTTP. What was the issue with TCP? So when you say client, when you say that, uh, is it moving? This is I say C minus S, client to server, and the opposite will be S to C, server to client. When client to server, after sending the thing, server kinds of shut down the connection because server's logic is based on the HTTP protocol. Uh, but what happens was, this is a system. Ultimately, this is a system, and this is systems in the network, right? Here there will be four layers downside. Here there will be four layers, five layers downside, and somewhere here TCP will be there. Somewhere here also TCP will be there. Now, when you are cutting this connection, the TCP connection between these two systems also should be cut. But the headache was, when you cut the TCP connection, the connection that was initially established between port of this and port of this port cannot be freed up immediately because um, port cleanup, RAM for this process and for that port has to be, each port will be having some buffer memory in order to store the immediate calculations or whatever. So, for example, think there are 100 requests and 100 ports are already blocked because after it depends on OS to OS. After some particular point of time only, this ports resources will get freed. I think maybe if port one is allotted to user one, when the user this connection is gone, the user two cannot establish connection with server A with the port one. He established with different port because that port is not freed up its resources. Similar way, after all these connections, 100 connections, all these ports are full, and when 101st connection comes, it cannot establish TCP connection. In the three-way handshake mechanism, TCP fails. Once you fail the TCP, above all the layers cannot communicate. Ultimately, two applications cannot communicate. So one was the solution for that is, do not close or do not cut the communication. That is how HTTP 1.1 came with. The perspective was keep alive connection should be keep alive, because closing or terminating the TCP connections was resource heavy, and it's a performance bottleneck. HTTP is meant to be fast because it's communication easy, right? Like, just call an endpoint, you are done with your task. And yeah, and in a similar way, there is a disadvantage with HTTP 1.1 also. It's called as high application level blocking something, where um, let's say a series of uh, res- multiple requests through the same connection happening, the first request taking long time blocking the second request in the queue. And that is how HTTP is evolved. Now we are in HTTP third version. For why am I telling all this? Because nobody knows the future. Like, nobody build for millions, nobody builds for crores of requests. People build for the present or current situation. Based on whatever happens to the system in the future, you should be able to make this applicable to the current situation without changing many things. Now someone cannot say, hey, ban HTTP, like, do not use HTTP, give us some time and we'll come up with the protocols. What happens between that time? What happens if that is delayed? So that is why understanding internals is such an important thing. And it's up to individual, right? One might be interested, one might not be interested. It's up to them. But if someone needs to enjoy this, or someone needs to enjoy the software engineering, deep dive into the abstracted concepts. You so better worst part is will fail. I deep dive into TCP and I lost my 3 months. It's not I lost my 3 months. You learned something there, some, maybe after 10-15 years the the dots will be connected. So yeah, from that's why this is where it tells, it justifies. See from the builder's perspective, if the person developing HTTP 1.1, HTTP 2.2 or 3 is not seeing this from builder perspective, will be never be able to come up with these things, and HTTP wouldn't have been such a protocol. Almost 90% of web applications or 90% of software applications rely on HTTP protocol. Today or tomorrow, I think I'm publishing a blog, in very in-depth blog, that whatever I'm speaking here, and that can be done here. So I think, yeah, that's what I wanted to say in the bigger picture, from where it all started and how come the dots are being connected. Yeah, this is the protocol version of it, and again, same thing, right? Protocols serves the communication. It doesn't matter if it's gRPC, WebRTC, or WebSocket, or SMTP, or whatever. Just the situation in which, or the medium in which communication happens will be different, and that's the birth of different protocols, right? And second one I wanted to say is agents. Second one I want to talk about is agents. Um, okay. It's already a long time, but yeah. Second one is I wanted. I'll tell just I'll connect agent with the protocols also. So, for example, now there are so many use cases or something like, okay, put a supervisor orchestrator agents, span up multiple sub agents, which does the small tasks, and give all the sub agents access to MCP tools or MCP servers or different tools, and spin up the task, make the task simple. But down the line, all this, when you say the communication is happening between supervisor agent invoke the sub agent, what is this invocation? This invocation is nothing but the communication that we saw here. This invocation is nothing but the communication. How supervisor is able to, agent is able to invoke the low level agent with the help of protocol. What is that protocol? A2A is one famous protocol, agent to agent protocol, developed by Google. And what is this A2A? A2A works on internally JSON RPC. A2A works internally in JSON RPC, and yeah, so that's why, like, all these are very vast and above picture. But if you see, it's like an inverted tree. The child nodes are more, but when you go deep, parent node is same. Networking and protocols and communications. When you say I invoked my supervisor agent invoked my sub agent one, but the response didn't come from sub agent one to supervisor agent, what might have happened? Connection might have been lost. Why connection might have been lost? That's again the same story. Maybe the resources would have been finished, or the connection just would have time out or something, whatever reason, right? At the end, all the dots are connected. So keep um, keep diving deeper into abstracted concepts. With this MCP and agentic world we are in, there are so many unknown blocks that we can't touch. For example, LLM is an unknown block. That LLM deep dive is a complete different vertical line, because that's needed the unimaginable skills of maths and statistical knowledge, and it's a deep thing, right? It cannot be learned in such a way. But now people are more interested in uh, what we build with LLMs, because earlier, if you see, the Coursera and other particular courses, Udemy, all the stuff, they used to have these courses like deep learning, neural networks, whatnot, whatever. and so on, etc., etc. Now the image is completely different because there are so many LLM providers. Google, uh, XAI, Grok, Gemini is from Google itself, OpenAI, Anthropic, Chinese models, Mistral, Llama, Meta, Quinn. There are n number of LLM providers, and after a certain point of time, with the capabilities of LLMs got increasing, all these concepts vanished so quickly. Nobody knows how it is generating a solution which has been not solved in 46 years. That nobody has answer for that. There is a mathematical problem which experts and world class mathematicians have tried, and you will see tomorrow in the news in LinkedIn saying that Anthropic Claude 4.6 model has solved a 46 years unsolved math question. Nobody knows what happened. Nobody knows which layer it happened. Nobody knows the weights of all the stuff. It's all moved very quickly. So you can keep track of small things like image classification, identification, but we are just beyond that. Yeah, yeah. So this is a black box that we don't want to enter into, because again it's a zero. Like you will end up at zero if you go inside this. Second thing, you now LLM has so much capabilities. Like it understands your voice, it understands your image, videos, everything. Text is the most primary thing that LLMs can understand. With that saying, and now mostly focus is on building applications with this. Many startups, application based startups like finance agents, insurance agents, or whatnot. Like more companies than, yeah, it's more startups which heavily rely on this application based agentic solutions and stuff. With those coming in, that brings the abstracted concepts. Since you want the applications to evolve, so as the technologies or components or libraries or frameworks also, and it's not possible to deep dive into everything that you touch. Again, like as I said, the leaf nodes might be many, but the parent node is one. So for something that connect the dots of somewhere else part. So yeah, that's what I wanted to discuss. It's so random thought, and I was so bored because of my hair dye with henna and stuff. So I thought, why not do a random thing, random chill stream, which is not topic driven, just open discussion. We started from hardware, OS, software, and where we ended up. And there are so many connecting dots we can connect. This is a good one. Yeah. Ending my stream. See you.